and build some skill sets here. So monomials and polynomials is what we're going to be working toward here. The idea is that we're going to work with some operations with those things today: add, subtract, multiply, divide, and then a few of the properties of those things as we go through this lesson. And then eventually, our goal is to be able to take a higher degree polynomial, something bigger than a quadratic, and break it down and be able to solve it using different skills. And graphs are going to be one of those things, which is why I want you to make sure you bring your graphing calculator tomorrow for that. And then doing operations and understanding how things go together and what things mean can help us be able to accomplish that goal. So monomials is where we're going to start, and then we'll get into polynomials. So a monomial is a number, variable, or the product of numbers and or variables. Some examples of things that are monomials. What does the prefix mono mean? One. So it's just one piece, okay? So just the number 7 would be an example of a monomial. Plain old number 7. It's a monomial. X, it's a variable. That's a monomial. And then the next part of the definition says it's the product. What's product in math? It's a multiplication problem. So if I multiplied 7 times x, that's still a monomial. So that's a product of a number and a variable. Well, we could even multiply number and more than one variable. That's still a monomial, 3x squared y. The reason it's a monomial is because it's one term. Terms are separated by addition and subtraction signs. No addition and subtraction signs here. It's either a single number, single variable, or a multiplication problem. That's what we're dealing with. Okay. Sweeney, can you turn around in your chair and not face the back of the room? Thank you. All right. So let's review exponent rules real fast. And then we'll get into actually practicing a little bit of this stuff and learning some of the rules as we go. So if I were to multiply x squared times x to the 7th, what's the rule for the exponents? You add them together. So that'd be x to the 2 plus 7, which is x to the 9th. We know that that's the rule. When you multiply variables or anything together that has the same base, the base is x, you add the exponents. Multiplication is add the exponents. What if there's a number or an exponential or a power inside of a parenthesis with an exponent on the outside of that? You multiply the exponents. So it'd be 3 times 2, which gets us x to the 6th power. Okay. So exponent rule there, it's the power of a power, so you're multiplying those exponents. Division. Subtract, yeah. So x to the 5 minus 3. Always the top exponent minus the bottom exponent. And then that'd be x to the 2nd power. And then the ones that folks sometimes struggle with are the negative exponents. How do you turn an x to the negative 2 power into a problem that doesn't have a negative exponent? You may remember how to do that. Drop it to the denominator of the fraction. That's what you do. And same rule applies if you have 1 over x to the negative 3. if it's negative in the denominator to start with, and you need to make it a positive exponent, you move it up to the numerator. Okay. We'll see that as we go along here. We never want to leave a negative exponent in our answers when we're simplifying these things. You always want to make it a positive exponent when you get done. Okay, so when you're simplifying, negative exponent in there, you got to fix it. Okay, and we're always going to fix that negative exponent last. The last thing that we'll do. All right, so let's do some problems where we're going to simplify. Number one, say we have 5x squared times negative 7x to the 6th. So throwing some numbers in there as well. What do we do with those numbers that are in front? Multiply them. All right, so 5 times negative 7 is going to be negative 35, and then x to the what power? 8th power. 2 plus 6 is 8. So we would end up with 35 negative, then x to the 8th power. Easy stuff. Let's go a little bit more difficult. Let's get more than one letter in there. 2a to the 3rd b in parentheses squared times 8ab to the 9th. All right, so what should I do first? Okay, so what gets squared then? Well, that's right. So what about the negative 2? Does negative 2 not have an exponent? It does have an exponent. It's actually an exponent of a 1. So it gets that exponent as well. So everything on the inside of that parentheses is going to get squared or multiplied. The exponents get multiplied by 2. So you really have negative 2 squared, a to the 6th power, b to the 2nd power. So order of operations tells us to do parentheses and then exponents first, then do multiplication and division. So we got to figure out this exponent here. What do you get when you square negative 2? Positive or negative 4? Positive 4. So I'm writing probably way more steps than I ever would if I were working this. What's next? Okay. What about the 8 and the 4 that are in the front? Multiply, that would be 32. A to the what? 7, B to the 11. And we're finally done. And again, you don't have to, I would expect you to do some of those steps in your head there. Or hope that you're working toward doing that. Going straight to that. All right, so multiplication there. And then we had the power of power rule there. Let's look at this one. 54, m to the 6th, n to the 4th, 3, m squared, n. So what operation are we dealing with here? Division. It looks like a fraction, but it's division. So what's the rule? Subtracting exponents. All right, and then the 54 and the 3 in the front, just going to divide those like normal, right? Or reduce the fraction as best we can. Does 3 go into 54? Yeah, 18 times. So we're going to get a whole 18 there. And then m to the what? 4th power, n to the 3rd. So we get both have positive exponents there, so I don't need to fix anything. Usually the division problems are where the negative exponents are going to come up, and you got to deal with those. Okay. Let's say we had, I'm going to contradict what I just said and throw a negative exponent into a multiplication problem, just so that we know that rule. What does that turn out to be? In the final answer, they can't be. So this is just the problem they gave us. it happens to have a negative exponent in it. But we're just going to follow our exponent rules. What operation are we doing here? Multiplication. So multiplication says multiply 2 times 10, get the 20. And then what do we do with our exponents? Add them up. So that's going to be 4 plus negative 7 will be negative 3. Now, once we've done that rule, we look and say, okay, now I got a negative exponent. I need to fix it. So I need to make it positive. So how do I make it positive? Move it to the denominator. Where does the 20 go? Why does it stay up top? That's right. What was the exponent on the 20? It's technically a 1. It's positive, so it doesn't need to move. The only things that move are things that have negative exponents. Okay, so if it doesn't have a negative exponent, it's going to stay where it's at. And then you're going to move the things that have negative exponents. I always do that last. Negative exponents I take care of last. Because if I move them to begin with, I may end up having to move them again once I do another operation. So I always just wait till the end to finish that off. And I think that's probably pretty efficient advice for you. One of the confusing things that happens with folks with exponent rules is the fact that you can do it in different orders and still get the same answers. Because when you're doing exponent rules, you're dealing with multiplication. And multiplication is commutative, and you can always do things in a different order, but and get the same answer. Exponent rules are part of that because that's what exponent rules relate to is multiplication. So you can kind of do them in different orders. I take the approach, like on a problem like this one, of looking at it as order of operations problems. What always comes first on order of operations? Parentheses. So I look on the inside of this and I say, okay, can I do something on the inside of the parentheses? What can I do? 14 and 7. That'll reduce to be 2. And then the rule is for the W to the 12th and the W to the 3rd is to subtract them, right? So it'd be W to the 9th. And then I've still got that negative 1 exponent on the outside. So I haven't done anything with it yet. So I'm taking this as an order of operations problem. So I started on the inside of the parentheses. If there's something I can do, I'm going to work it out. But if there's not, then I apply the exponent rules. Well, I've worked out the inside. Now I got to apply the exponent rule. So what gets a negative 1 exponent? Everything. So the 2 gets a negative 1 exponent. The W becomes a negative 9 exponent. Everybody has a negative exponent. So where do we move them to turn them to positive? The bottom. So that's 2W to the 9th. What's up top? A 1. If everything moves, there's a 1 there. Throw some fractions in there because everybody loves them. I've been sitting there just waiting for a fraction problem. Right. So we have 2/3 x squared y to the 7th. That's all in parentheses and it's squared on the outside. And then the other parentheses is 1/6 x cubed y. All right. So what do where do I start? All right, so I can't do anything to simplify the inside of either parentheses, so I'm going to go ahead to the exponents. And this one has an exponent on the outside. So what gets the squared? So how do you square 2/3? Yeah, square both of them, the 2 and the 3. So that's going to be 4 over 9, x to the 4th, y to the 14th, right? And we're multiplying that times 1/6 x cubed y. So it's 4 and 6 are divisible by 2. So it's going to be 2 on the top, 27 on the bottom. X to the what? 7, y to the 15, 14. All right. Now, I wrote that with the x and the y in the top of the fraction. How else could I write that and it be correct? To the side of the fraction. That's right. You could write it 2 over 27, x to the 7th, y to the 15th. Now, I prefer the one that I've boxed in because it's obvious where the x and the y are. Sometimes when folks write their fractions, I've had students in the past that like to write fractions like this, and then they would put x squared or x to the 7th, y to the 15th. Where does it look like the x and the y are? On the bottom when you write it like that. So that's why I write it the way it's in the box there. It means the same thing as the one to the right, but this one, it's not as obvious what it means. So I prefer that you don't write your fractions with a sideways slash like that. Don't write them like that. If you're going to write a fraction, write it vertically so it's a little easier to tell, because I'm a lot of times give you the benefit of the doubt, but with this stuff, I've got to be really picky about where the x and the y are, because it could be on the top, it could be on the bottom, based on that. So we've got to be picky about that. So I think if you'll take the approach that I've boxed in here, it's better for you. And me too. It's easier for me to grade anyway. All right, let's look at this one. 15, x to the 10th, y to the 4th, or 24, x to the 12th, y to the 3rd. Excuse me. So just got a fraction going on here. Remember, fraction is just a division problem, but we're going to reduce that fraction in the simplest terms. All right. So the 15 and the 24, both divisible by what? 3. So that's going to be 5 and 8. What's the rule for the exponents? So 10 minus 12 would be -2. So I'm going to put x to the -2 up top. Anytime you do the subtraction rule, the division rule for exponents, you're going to put your answer in the top to start with. We know that what's going to happen to the x to the -2, it's going to go to the bottom and become x squared. But if you'll just humor me here, and then it'll be y to the first power up top, which I don't have to write the 1. Now I fix it 5y over 8x squared out of that. So anytime you do the subtraction rule for exponents, then you're going to put your answer in the top, even though we know negatives are going to drop to the bottom. A lot of times folks will double move a term instead of just moving it the one time they should. So if you'll just be careful of that. Let's do this one. X over x squared to the 4th times -3x to the 4th. Kind of a crazy looking one. Several different approaches to doing this one, so let's pick a way. So what do we want to do? You could distribute the exponents. That's one way. I think there's a little bit of an easier way so you don't have to deal with so many numbers. I could go ahead and subtract these right here because they're the same base, right? Got an x and an x. So that'd be 1 minus 2, which would be x to the -1. And then on the other one, I think I do need to go ahead and distribute the exponent and get -3 to the 4th power and x to the 4th power. And so the next step would say, oh, well, that's actually x to the -4. What's -3 to the 4th power? Positive or negative? Positive. And x to the 4th. What happens to my x's? What's the real exponent that's on there? That canceling out is really what happens, but it's 0, and anything to the 0 power is always not 0. It's 1. So that's why it's going to be x the x is going to cancel out and get us just 81. Because what times 81 gets us 81? 1. That's the only way to get that back. 81 is our answer choice there. So anything to the 0 power, even if it's x or pumpkins or, you know, Thanksgiving turkeys to the 0 power is 1. Always. Okay. Number 9. Negative 36 m to the 4th n to the 7th over 12 m to the 8th n to the 5th. What do we do with this one? Okay, so the 36 and the 12, will that divide evenly? Yeah, so that's negative 3 m to the negative 4 n to the 2nd. Now let's fix the ones that need fixing. What needs fixing? That negative 4 on the m. So what's it do? Does anything else go with it? No. So m to the 4th on the bottom, negative 3 n squared stays up top. Yeah, we've done that. Again, exponent rules, things that you've been doing for years, the negative exponents tend to be the place that catches a lot of us. And you haven't worked with those as much as you have the others. So, but anyway, exponent rules, got to know those. Now, let's talk about polynomials. You got a question or just number 5? Yeah, because it had that negative 1 exponent. And so that's why it moved, because it had a negative 1 exponent. All right, let's talk about polynomials real quick. And that's where we'll spend the rest. Polynomials. Polynomials. What does the prefix poly mean? Not just 2, but it could be 2, 3, 4, anything bigger than 1, right? Poly means many. Okay, so polynomials is going to be the sum or difference of monomials. So sum is what? Addition. Difference is subtraction. So when we're dealing with polynomials, we're going to see pluses and minuses in our problem. Monomials, no pluses and minuses, all multiplication or division. So with polynomials, we got monomials separated by addition and subtraction. Inside of a polynomial, we've got this thing called a degree, and the degree of a polynomial is the largest exponent or sum of exponents for a term in the polynomial. Okay. Degree is going to be an important thing as we start tomorrow. We'll start working on solving some polynomials and things, and that's where the graphs are going to come involved too. The degree, when we just finished this whole unit on quadratics, and what was the largest exponent in a quadratic? X squared. So the degree of a quadratic is 2, right? And how many answers did we find on quadratics? 2 every single time. Even if it was a repeated solution, there was always 2 of them, right? So the degree of a polynomial, we're going to be dealing with bigger polynomials, x cubed, x to the 4th, x to the 5th. It's going to help us know how many answers we should be finding out of that. So degree is an important thing. It's a property of a polynomial that helps us when we start looking at what's happening with the graph and what's happening with the zeros and things, or roots or solutions to a polynomial equation. All right. Last thing with polynomials that we'll kind of focus on here is the standard form. Standard form is just descending order. Okay, descending order. We want to start with our highest power of the variable and go down, just like we did with quadratics. Nothing different there. So descending order is going to put us in standard form for a polynomial. So the first few examples we're going to do here, we're going to write in standard form and state the degree. Let's say we had 8x minus x to the fifth minus 1 minus 3x cubed plus 1/4 x squared. So there's our polynomial that's just handed to us, and the instructions say to write that in standard form and then state the degree of that. So to write it in standard form, that means put it in descending order. So what would come first? The x to the fifth. So what kind of x to the fifth is it? That's a negative x to the fifth. So that's what we're going to put there. And then what would be next? The negative 3x cubed. And then next, that's 1/4 x squared. Now, what with the 8x? Do I add or subtract? I add because it is what kind of 8x? Positive. So that's why the plus sign. And then last term would be -1. So each individual piece that's separated by addition or subtraction is a term. Okay. To find the degree of the polynomial, you really are supposed to look at the degree of each term. Since there's only one variable for this thing, we just look at that first term. If we got it in descending order, the first term should tell me the degree, right? There's only one variable. So this one, first term, has an exponent of 5, so the degree is going to be 5. Okay. Where it gets a little bit more complicated is when they throw more than one variable in there. So this one is 18a squared b squared minus 7ab minus b squared plus 4a to the third. Okay. So when there's more than one variable, descending order can get like, which one do you go by? So we have to set a rule for that. So the rule that every mathematician that I know of goes by is to start with, you go descending order by the letter that's first in the alphabet. So for this one, A is the first one. If they used X and Y, you'd use X. If they use J and K, you'd use J to go by. So you always go by descending order by the first letter in the alphabet. So A is the one we're going to go by here to put it in descending order. So what would come first for descending order on this one? 4a to the third, or 4a cubed, whichever way you want to say that. Next, 18a squared b squared minus 7ab, and then minus b squared. Okay, so again, the b squared, the b's don't really matter what order they're in. We're going by a is what we're going by for descending order. Now we need to look at degree. And with the first example, example 10 there, it was easy because we only had one variable to deal with. So it was just the biggest exponent. With this one, because it has two variables, you really have to look at every individual term and get the degree for each term. So what's the degree of this first term? Okay, so what's the degree of this term? 4, the sum of the exponents. Remember that definition? It said the sum of the exponents. So the exponents are 2 and 2, so you add them together, it's 4. Okay, so that's bigger than the 3. So far, 4 is our degree. What's the degree of this term? 2. 1 plus 1. Degree of this term? 2. The biggest of all of those degrees is 4, so that's the degree of the polynomial. Degree 4. Okay. All right, let's look at another one. 5xy squared minus x squared plus 9x to the third y minus y to the fourth plus 2. We're going to put that in descending order and then state the degree. So which one are we going? Which one do we go by to do the descending order? X comes in first in the alphabet. Takes you a while to get there. That's the 24th letter, so takes a while to get there. So X goes first. So we look at the powers of X, and we start with 9x cubed y, right? Because that's got the most x's. And then the next would be negative x squared. And then 5xy squared. And I'm going to put the minus y to the fourth next and the plus 2 last. Technically, since neither of those have an x, it really doesn't matter which one. But the commonplace thing to do is put your letters before you do the plain numbers. But I wouldn't count off if you wrote it 2 and then minus y to the fourth. Now, degree. What's the degree of the first term? 4. What's the degree of the second term? Third term? 3. Several different answers there. And the degree of the fourth term is, and the degree of the last term. Are there any variables on that term? No. So the degree is 0. If it's just a plain number, the degree is 0. Okay? Plain number, degree 0. So this one had a degree of 4. This term had a degree of 4. It's a tie, so it's just 4. So degree is 4. So there's the descending order and the degree for that one. Okay? So being able to find that degree and all that stuff, that's a skill that we need. All right, the next thing we need to be able to do is to classify by degree and number of terms. So I'm going to make a little chart here. And then need that much space. There we go. All right, so degree. If it has a degree of 0, it's just a plain number. So it'd be like 2 or 7, something like that. That is called constant. It's a constant polynomial. So it doesn't have a variable on it. It stays that number forever. If there is a degree of 1, and we'll go ahead and write these in there, 2, 3, 4, and 5, and then it continues after that. So the degree is 1. It's linear. We did this back in the early part of the semester. We're dealing with linear equations. Y equals mx plus b in slope-intercept form. Then we look at the x. The x has a exponent of 1, so the degree is 1. So linear terms have a degree of 1. The degree of 2 is called what? Quadratic. That's what we just finished up. The degree of 3, if it's x to the third power, what's another way of saying that? x cubed, so this would be a cubic. And fourth power, you don't hear a lot of people saying this anymore. Quartic is the official word for it. You will hear me say fourth degree polynomial more often. That's the more modern way of saying it. Older generations used quartic. Does anybody know what fifth degree would be, what the word is? Quintic. Anything bigger than that, I'm going to go. You're like I said, you're going to hear me say fourth degree, fifth degree, sixth degree, seventh degree, eighth degree. We're not going to get that big in Algebra 2 for sure. But these first four here, constant, linear, quadratic, cubic, those are set. I need you to use those words. But the rest of them, I'm fine with fourth degree, fifth degree, sixth degree, that sort of thing. Okay. Now let's look at number of terms. If there's only one term, what's it called? We already talked about it today. A monomial. M-O-N-O. If there are two terms, it's a binomial. There's three terms. Trinomial. There's four terms or more. We're just going to call it a polynomial. So anything with four terms or bigger, we're just going to call it a polynomial. Okay. All right, so let's classify a few. Then we'll get to do some operations here. Classify and by degree and number of terms. Negative 3x plus 1. What's the degree of that? 1, so that's called a linear. How many terms does it have? There's a plus sign in it. So this is one term, this is the second term, so it's two terms. It's a binomial. It's a linear binomial. What's that? Quintic. Another way of saying that would be fifth degree. So either way, I'm okay with either way there. I'm going to write fifth degree because that's what I catch myself saying most of the time. Fifth degree. How many terms? Trinomial. Fifth degree trinomial. If you wrote quintic, that's fine too. (31 minus x squared minus 18x). Is that one in standard form? No, but can we still classify it even though it's not in standard form? Yeah. What's the degree? So it's quadratic because the degree is 2, right? And it's a trinomial. Quadratic trinomial. All right. 3x cubed minus 9x squared plus 15x minus 45. Cubic. Just polynomial. Anything with bigger than 3 terms, you just call it a polynomial. You don't have to remember a special name for a number of terms after 3. So cubic because it's got x cubed as the biggest piece, and then a polynomial because it's got 4 terms. All right, easy stuff there. Really, really basic. All right, let's do some math. We ain't done any today. So let's simplify. So this is where we're going to do addition, subtraction, multiplication, and even some division with this, with polynomials. And it, when you're doing addition, subtraction, start with that. 3x squared plus 11x plus 4 plus another polynomial. So we had negative 5x plus x squared minus 13. So it's two different polynomials that we're adding together. What do we put together when we were adding? Like terms, that's right. Like terms, that's all you're doing. What order do you want your final answer to be in? Descending order, always in descending order. So when we're doing that math, we're going to look for the biggest power of x in each polynomial and put the like terms together. So the first one has 3x squared, 11x, and 4, so 3x squared is biggest. And does it have a like term? Yeah. So 3x squared plus x squared would be 4x squared, right? And then we go to the next term down. So 11x and the negative 5x, put it together, plus 6x, and then 4 plus negative 13, negative 9. So we've put that together, and we could classify that by degree and terms if we needed to. What is it called? Quadratic trinomial. Okay. And since we just finished quadratics, if we needed to solve that, we could set it equal to 0 and solve it. All of those things that we already know how to do are going to come back up as we do this work here. So here's a polynomial. And we're going to subtract another polynomial. 5x cubed minus 2x squared plus 2x and then minus the polynomial 2x squared minus or plus 2x plus 17. We're putting together those two polynomials. So again, what order do we want our answer to be in? Descending order. So the first term that we should start with is what? 5x cubed. So we start with 5x cubed. Is there a like term that goes with it? 5x cubed doesn't have anybody else that's got an x cubed on it, does it? So to be a like term, you got to have an x cubed. So 5x cubed is the first term. And now what? The negative 2x squared minus 2x squared is negative 4x squared. And then we've got plain x's, 2x minus 2x. What happens to that? They cancel out. They go away. The 0x, you cancel it out. And then we have a minus 17. Most common mistake on that problem is folks miss the minus 17. They'll put plus 17, which is wrong. You got to be careful of that sign that's in front. Some people like to distribute the minus sign and then put it together. I don't care which way you do it. I don't do it that way just because I don't think it makes it any better. If I can't remember that minus sign, I probably, gonna miss it anyway. Let's do one that's got more than one variable. So negative 10ab plus 7a squared minus b squared minus 8b squared plus ab minus 2a squared. Addition's too easy, so we don't do very much. All right, so we got two variables in this thing. So that means we've got to be careful about our descending order. Which letter do we go by? A, because it comes first in the alphabet. Okay. So what do we start with? 7a squared minus negative 2a squared. 9a squared. Different color. 9a squared. Right? Now what? Minus AB would be negative 11AB. And then what's next? Negative b squared minus 8b squared, which would be negative 9b squared. What's the degree of that polynomial? 2. What's the degree of the first term? What's the degree of the second term? What's the degree of the third term? Can't mess that one up, can you? Can miss the degree on that one. All right. So we've done addition. We've done subtraction. Let's do some multiplication. We've been doing this for years. We just didn't call them polynomials. We just called them monomials or something like that, or we just called it. What property are we doing here? Multiplication using the distributive property. That's all we're doing is distributive property. X times x, x squared, x times negative 5, negative 5x, 3x, negative 15. Put the like terms together. Yeah. Again, hopefully you're getting faster at that, and you might could leave the red step out and do it all in your head. Because you've been doing this a while, we should be getting faster at doing that kind of math. All right. What if we got an x minus 7 times the trinomial? So we got a binomial times a trinomial. Still going to distribute, right? Like, wonder if it's the motion. Is that what it is? All right. So when I distribute, I'm distributing x, right? So that'd be x cubed plus 2x squared plus x. And then I'm going to distribute the minus 7. I'm going to show you how I like to do these, because as the problems get longer, organizing your work gets a little bit more necessary. You know, it's not this difficult because distributing a negative 7 is not real hard, but putting the like terms together, if you stretch that thing out across the whole page, you got to hunt around to find your like terms. If you'll stack it up, it makes things a lot faster. And if you can save yourself 5 seconds on the ACT math problem, and you do that 2 or 3 times, you've suddenly got 30 seconds extra that you can put on another problem out of that. So if I distribute the negative 7, that's going to be negative 7x squared minus 14x and then minus 7. I'm stacking up like terms and then just putting it together. X cubed minus 5x squared minus 13x minus 7. It probably isn't that much of a help on this problem, but on this problem, it might be x plus 2 times x cubed plus 5x squared minus 3x plus 9. Not a harder problem, just a longer problem. And it's not necessarily that you can't multiply correctly and add and subtract correctly. It's that when you stretch it out over a long space, you can forget a piece. So that's why I like stacking it up. So x times x cubed would be x to the 4th plus 5x cubed minus 3x squared plus 9x. And then distribute the 2. That's going to be 2x cubed. And it's a positive 2, so I'm going to put plus 2x cubed plus 10x squared minus 6x plus 18. So I'm stacking up like terms. And then that makes it a lot easier to just put together. X to the 4th plus 7x cubed plus 7x squared plus 3x plus 18. So anytime that we can get like terms to come together a little easier, I think that's a handy thing to have. Even more so when you have a trinomial times a trinomial. So you have two problems that have a degree of 2, and you're multiplying them together. So the degree of our answer will be what? 4. Thinking about degrees, if I multiply something that has a degree 2, the first piece, times something else that has a degree 2, then multiply the degrees together, you get the final answer should have a degree of 4. That can help you later on. So I'm going to stack it up again. So I'm going to distribute x squared. So that's 3x to the 4th minus 5x cubed plus 2x squared. And then I'm going to distribute 7x. So that's going to be plus 21x cubed minus 35x squared. And then plus 14x. 7x times negative 5x. X times x, x squared. And then the last piece is the 12. 12 times 3x squared would be 36x squared minus 60x plus 24. To me, that just looks a lot easier to do than if I stretch it across the whole page. Stretching it across the whole page, you got to hunt around for like things. This way, hey, they're right there. It's 3x to the 4th plus 16x cubed plus 3x squared. Oops, not plus, but minus 46x plus 24. So again, the stacking is just a strategy. It is not the only way to do that, but it's just a strategy of how to get things to come together a little easier. All right. So one of the things that we're going to be building up towards is taking a larger polynomial like what's boxed in here and breaking it apart into smaller pieces that we can solve. That's what our goal is ultimately in this whole unit, is to do that. And we would end up getting a problem that looks something like this. So it's like the factored form of a larger degree polynomial out of that. So what was the other, when we were doing quadratics, if you just had 2 of these things, what was that form called? Anybody remember? You had standard form, vertex form, and the other one was called intercept form. What were the intercepts that we were finding? The x-intercepts, right? We spent tons of time learning all the different ways to find x-intercepts. When we're dealing with higher degree polynomials, that's what we're doing too. We're trying to find all the x-intercepts out of that. If you could rewrite it into this form, it's going to be really easy to find those x-intercepts because then you just set each piece equal to 0 and solve it, right? So what we're going to be building up to in the next few days is being able to take something looking like that and break it down until it ends up looking like this. And then we get all the x-intercepts pretty easily. Okay? So if we're going to break down to this, we need to be able to build up to that. So let's multiply this together. So does it matter what order I multiply things together in? Why not? Because multiplication is has what property? No. Commutative property. Commutative property means you can do it in whatever order you want to and you get the same answer. So I'm going to do it in this order. I'm going to save the multiplying by -3 for last because that's super easy. And I don't have to do that. Yeah, it's bugging me too. I don't understand. So we're going to multiply x minus 2 times x plus 8 first. If I wanted to multiply these two together first, I could. If I wanted to multiply x plus 5 times x plus 8 together first, it's okay to do that. It doesn't matter which way you do that. But just pick two of them to start with. I'm going to pick the two at the right and just work my way from right to left. And that'll give me x squared plus 6x minus 16, right? And then I'm going to distribute the x plus 5 to that trinomial that's left there. So that would be x squared plus, or x cubed, excuse me, plus 6x squared minus 16x, and then plus 5x squared plus 30x minus 80. And I'm going to simplify that part. Okay. And then distribute the -3 at the end. And there we built this big polynomial. So multiplying it out, it doesn't matter what order you do that in. If you want to multiply out the -3 to the first parenthesis and then distribute everything, that's fine. You can do that. I don't care. You just got to end up multiplying by 3 and 15 instead of 1 and 5, which I'm better at 1 and 5 than I am 3 and 15. Let's do one that kind of puts together the addition and subtraction with multiplication. 2x plus 1 times 4 minus 9x minus 2x times 3x plus 11. Five more examples, guys. Just stick with me. What do I do first? All right. Multiply, distributed property, all through that problem. Do all of that. Order of operations says parentheses, exponents, multiplication, division, then addition and subtraction. So I've got to do all that stuff first before I can do the subtraction. So I'm going to do 8x squared, or excuse me, 8x minus 18x squared plus 4 minus 9x. And then what am I distributing on the second part there? Just a 2x? A negative 2x. I'm going to distribute the sign with it. Okay? So that so I get a little easier work there. So negative 6x squared minus 22x.
At this time, we need everyone to turn their heat off in the building. If you have heat running, turn it off right now, please.
I wonder if they're changing out some parts or something in the boiler room or something. All right. So now, like terms, what do we start with? X squared. So negative 18x squared and negative 6x squared is negative 24x squared minus how much? 23x. Y'all agree? I hope so. And then plus 4. No other like terms with that 4. And there we've got that as a nice little polynomial. All right, so we've done addition, subtraction, multiplication. Let's do some division real quick. 9m to the third minus 24m squared divided by a monomial 3m. Okay, so this is similar to when we did the quadratic formula stuff, and we had two different. You had like 10 plus or minus the square root of 17 over 3, or something like that, and you could split it up into two different fractions. It's the same idea with this. You want to split this up into two separate fractions, so that you're getting 9m to the third over 3m minus 24m squared over 3m. And then you simplify each fraction individually. Whether you do that in your head or write it out like that, doesn't matter to me. Some of you can do that stuff in your head, and that's fine. But 9 and 3 becomes 3, the m squared, right? 3 goes into 24 8 times, and 2 minus 1 be 1. So it's going back to the same division stuff that we had done in the past there. Nothing changing there. I'm about to lose you guys, so I'm going to skip one. Let's look at one that's a little different. 3x squared on the bottom. Again, we're going to split that apart. Anytime we're dividing by a monomial, which is what we're doing today, we're not dividing by anything bigger than a monomial. We're going to take and split it into three fractions. So it's 30x cubed over 3x squared minus 12x squared over 3x squared plus 9x over 3x squared. And we're going to simplify each fraction. So what would the first one be? 10x. Try again. 10x. And then the second one would be minus 4, no x's at all, because the x squares cancel each other out. What's the last one end up being? 3x to the negative 1. Can we leave a negative exponent in our problem? Is that in descending order? Yeah. All right, so biggest power of x. Positive 1. That's in the front. That's a 0. And that's a negative 1. So it is biggest to smallest. It just looks weird. So let's fix it so that the negative exponent's not there anymore. So that would be 10x minus 4 plus what? 3 over x. Okay. All right. Let's do one with more than one variable, just so that we have seen that, and then we'll be done for the day. 40m to the third n to the fourth minus 24m squared n to the seventh divided by the monomial 8m squared n to the fifth. So that's our monomial. Split it up and work it out. 40 split them up, simplify each one individually. So that's going to be 5m n to the negative 1, 3 n squared, right? How do we fix that? Put the n on the bottom. So it's 5m over n minus 3n squared. Is that in descending order the right way? Which letter do we go by? M, because it's first in the alphabet. Okay. That's the check that.